Despite being the richest person on Earth, Elon Musk doesn't see himself as a businessman.
I've heard people say, listen, he's an out-of-the-box thinker, he's a businessman, he's an entrepreneur. But people that know
really
you say...
Really a businessman, I wouldn't say.
You would say?
I'm not really a businessman.
You're not a businessman? No?
No.
What are you?
I'm an engineer.
An engineer?
Yeah.
For most of modern history, the world's richest weren't engineers.
They were industrialists and financiers who controlled physical assets, oil fields, steel mills, railroads, and banks.
But the richest today are not traditional business people. They're engineers, programmers, and technical founders.
Take Jensen Huang, the CEO of NVIDIA. He majored in electrical engineering at Oregon State, where he became fascinated with circuit design. In 1993, he co-founded NVIDIA to build graphics processing units for video games. NVIDIA's chips were used to render 3D graphics, lighting, textures. GPUs were extraordinarily good at performing many calculations simultaneously.
That turned out to be useful for far more than gaming.
In 2013, a junior engineer at NVIDIA, Bryan Catanzaro, began experimenting with using GPUs to train neural networks.
AI was still in its infancy, and when he brought it to management, they dismissed him. But he believed he was onto something, so he went directly to Jensen Huang.
Huang was immediately intrigued. He cleared his entire weekend to immerse himself in AI research papers. By their second meeting, Catanzaro was stunned to see that his boss now understood the subject just as well, if not better, than him. Huang realized NVIDIA was no longer just a gaming company. Its chips could become the computational foundation for artificial intelligence itself.
We're going to be collecting enormous amounts of data. And all of this data could contribute to helping machines be smarter.
It was like an epiphany.
As David Kirk, NVIDIA's former chief scientist, told author Stephen Witt of The Thinking Machine, he got it immediately, before anybody. He was the first to see what it could be. He really was the first. His engineering mind let him see the greater potential and gave him the foresight to shift the entire company's focus. Inside a conference room at NVIDIA, Huang erased a whiteboard and wrote OIALO, which stood for Once in a Lifetime Opportunity. Today, NVIDIA is at the center of the AI revolution. Its chips power ChatGPT, autonomous vehicles, robotics, drug development, and the most powerful supercomputers ever built.
This is the first office of Amazon.com Inc.
Jeff Bezos isn't primarily known as an engineer.
This is my desk here.
But he thinks like one. When Bezos launched Amazon from his garage in Seattle in 1994, he was obsessed with being frugal. Instead of buying expensive office furniture, he built desks out of cheap wooden doors from Home Depot held together by 4x4s. The door desk later became a symbol of Amazon's frugal culture. He viewed Amazon less as a store and more as a self-reinforcing machine. That idea became known as the Amazon Flywheel. Rather than maximizing profit on each individual sale like a traditional retailer, Bezos designed a self-reinforcing system. Lower prices attracted more customers increased sales volume and attracted more third-party sellers. More sellers expanded selection and lowered per-unit costs through greater scale and efficiency. Lower costs enabled even lower prices. The cycle reinforced itself. This kind of feedback loop thinking lies at the heart of engineering.
That same mindset showed up in another idea at Amazon that was deceptively simple but brilliant.
In 1999, Amazon patented its famous one-click purchasing system, allowing customers to buy an item with one click using pre-saved payment and shipping information. Most retailers treated checkout as a simple transaction, but Bezos treated every extra click as friction. The more friction in a system, the more likely customers were to abandon their carts. By removing friction through one-click shopping, Amazon significantly increased conversion rates.
But Bezos was thinking far beyond online shopping.
In 2006, Amazon launched what sounded like a bizarre idea. It decided to rent out its computing and storage services to other companies over the internet. At the time, most businesses operated their own physical servers and data centers, which were expensive to build and maintain. Today, AWS powers huge portions of the internet, from Netflix to Airbnb to financial institutions. While Bezos helped build the infrastructure powering the internet, 2 Stanford PhD students were trying to organize the internet itself. Before Google, search engines were surprisingly primitive. Web pages were ranked based on how many times a keyword appeared on a page. But that's problematic because a web page could rank highly simply by stuffing, for example, cheap flights all over the page. Larry Page and Sergey Brin wanted to figure out how to get actual quality results. Their breakthrough was to treat links between websites like citations and academic papers. In scholarly papers, a citation from an important source carries more weight than one from an obscure source. The same logic could apply to the internet. If a trusted website like NASA's linked to another web page, that acted as evidence the page was important. They turned their idea into PageRank, the algorithm that became the foundation of Google. Page and Brin showed that two computer scientists could build systems capable of reaching billions. Mark Zuckerberg took that to a whole new level. He personally wrote much of Facebook's early code from his Harvard dorm room. Zuckerberg didn't launch Facebook to everyone immediately. He rolled it out gradually, first to Harvard, then other Ivy Leagues and elite universities before the general public. That exclusivity made Facebook feel more trustworthy and socially valuable, allowing it to grow rapidly, organically. Facebook's early motto captured that engineering culture perfectly. Move fast and break things. Perhaps no billionaire embodies that move fast mentality more completely than Elon Musk. It was already apparent when he started his first company. He and his brother Kimball had the idea of building an online business directory and combining it with map software for navigation years before Google Maps existed. They called it Zip2, as in you could zip to where you wanted to go. He slept in the tiny office they rented and worked non-stop. Former colleagues said Musk would sometimes rewrite other engineers' code overnight after they went home because he wasn't satisfied with it. Walter Isaacson's biography describes how, like Steve Jobs, Musk genuinely did not care if he offended or intimidated the people he worked with, as long as he drove them to accomplish feats they thought were impossible. Musk was drawn to problems considered impossible. Rockets had always been extraordinarily expensive and not reusable. Although the space shuttle's boosters could be fished out of the ocean and refurbished, it became enormously costly. Musk approached the challenge of reusable rockets through first principles thinking, breaking rockets down to their fundamental components and asking why they couldn't be reused like airplanes.
In exclusive footage I obtained, Musk explains his approach to a group of students.
You look at what others are doing, say, well, others didn't make it work, therefore it doesn't work. That has no basis in reality. A first principles or foundational approach would be to say, let's look at the physics and economics of a rocket and say, if we analyze the physics of the rocket, is it physically possible?
Using this approach, SpaceX designed Starship, the world's largest and most powerful rocket, to be fully reusable, something long considered economically unrealistic. If SpaceX becomes the most valuable company on Earth, Musk could become the world's first trillionaire. The modern billionaire is increasingly not a financier or industrialist, but an engineer.
Technology has changed that equation.
Engineers and programmers can create products used by billions of people without owning vast amounts of resources. They've become a new kind of billionaire, and many of them weren't primarily focused on making money. They were obsessed with building the future, and the wealth was often a byproduct.
One thing the billionaires in this video had in common was an obsessive focus on productivity. Researching these videos used to take a lot out of me. I was constantly jumping between dozens of tabs, articles, and book PDFs. That's why I started using Genspark AI, an all-in-one workspace that combines GPT, Claude, Gemini, and more in a single platform. One feature I love is deep research. For this video, I wanted to figure out when exactly Facebook expanded from Harvard to other universities. Instead of spending a lot of time piecing it together myself, Genspark quickly delivered an accurate timeline in seconds. They also have a powerful workflow feature. I get flooded with emails every day from sponsors and tons of spam. Now every morning I get a clean summary of my unread emails, categorized by what needs my immediate attention. It's also incredible at creating presentation slides. I told it to create 10 slides on NVIDIA's Rise, and it generated them in seconds. And clearly, I'm not the only one who finds it useful. Genspark has reached a staggering 250 million annual run rate in just 12 months, making it one of the fastest growing AI tools out there. And right now, paid users get unlimited AI chat and unlimited image generation. They're also offering a Get Started bonus where new users can try premium features like AI web app building and deep research for free. If you want to check it out, you can use the custom link in my description. Thanks for watching. For Newsthink, I'm Cindy Pom.